Okay, so now let's try to discuss maxima and minima question. So this is question number one. What is the maximum value of this particular function? Okay, in the interval 0, comma 2. So it is closed interval, right? Closed interval means 0 and 2 is included, and this is open interval 0, comma 2. It means that 0 and 2 is not included. Okay. Now, in order to find maxima and minima, what is the steps we have to follow? Minima. Suppose we have given the function f of x. Okay. So first step is to differentiate f of x. Okay. So f dash of x be a differentiation of this f of x. In the second step, equate that differentiation to 0 to find out stationary point. To find out stationary points. Okay. Then in the third step, differentiate f dash of x again. So it will be f double dash of x, right? And suppose x0 and x1 are the stationary points. Okay. For example, then differentiate this f dash of x. So this will be a double differentiation of f of x. Then put x0 and x1 in f double dash of x. If double dash of x0 or x1 is greater than 0, it means it is positive. In that case, this function f of x will obtain a minima. Will obtain a minima at x equals to x naught. Right? Suppose and if f double dash of x is less than 0, that is basically a negative, then we can say f of x will obtain a maxima at x equals to x naught, uh, or any value if we put, or any stationary point if we put, right? When f double dash of x is greater than 0 or positive, f of x will obtain a minima at x equals to x naught. If f double dash of x naught is less than 0, that is negative, then f of x will obtain a maxima. And the maximum value of f of x. So maximum value of f of x will be f of x naught if this condition is satisfied, right? But if this condition is satisfied, then the minimum value of f of x will be f x naught. Okay, so please remember this important point. So we'll try to discuss this example, and we'll try to follow the same steps. Okay, so this f of x is given to us, right? Now f of x is basically 2x square minus 2x plus 6, right? If I differentiate f dash of x, so it will be, so you should know how to do a differentiation of f of x, right? So 2 into x square, that is 2 into 2, that is 4x minus 2. Just equate it to 0. So f dash of x equals to 0, that is basically 4x minus 2 equals to 0. So from this particular expression, I will get x equals to 1 by 2, right? So that is my stationary point. Now again differentiate f dash of x. So what I will get? 4 only. Okay. So this is positive. It is greater than 0 irrespective of the value of x, right? This is positive. So it means my f of x will attain a minimum value, okay, at x equals to 1 by 4, right? So here I will not get the maxima in this for this particular expression. But how to find out the maxima? So here we have given this particular interval, closed interval, right? So what is maximum value? This maximum value, it will be a maximum of f of a comma f of b, and it is local maximum. Okay, local maximum. So whatever we are calculating, this one and this one, it is for local maximum or minimum. And what is a or b? It is closed interval of a comma b. Okay, so just try to put f of a and f of b in this particular expression, that is f of 0 and f of 2. What we will get? So f of 0 is basically 0 minus 0 plus 6, it equals to 6. F of 2 will be what? 2 into 2 square, that is 4, into 2, 8. minus 2 into 2, that is 4, plus 6, right? So it will be 14 minus 4, that is basically a 10. And here we don't have any maximum value. So here we don't have any local maxima. So maximum value will be maximum of 6 and 10, that is basically a 6 f of 0 and f of 2. So maximum value out of 6 and 10 will be 10, right? That is basically the maximum value of this particular function f of x is 10. Okay, so this is the correct answer. Just remember this point. If in the exam it is asked for maximum value, it means a global maxima. Okay, it is a global maxima, global maximum value. So what is global maximum? It is basically, or absolute maximum, it is basically a maximum of f of a comma f of b and comma local maximum. So here we have local, so here we don't have any local maxima. Okay, so I hope you understand this particular concept. That's it. Okay, so here the function is given to us and we need to find out maxima or minima, right? So same steps we can apply. Take the derivative of f of x, that is basically x cube, so 3x square minus 12x plus 9, right? Find out the stationary point. Find out the stationary point. So f dash of x equals to 0. So basically 3x square minus 12x plus 9 equals to 0. Just divided by 3. So x square minus 4x plus 3 equals to 0. Okay, so root of this particular expression will be x minus 3, x minus 1 equals to 0. So x equals to 3 comma 1. So I have x equals to 3 and 1. These are the stationary point. Okay, so this is the stationary points. Now again I need to differentiate this f dash of x, right, in order to find out maxima and minima. So f double dash of x will be 6x square minus 12. Now just try to put the stationary point in this f double dash of x. F double dash of 3 will be 6 into 3 square minus 12. So 9 into 6, that is 54. 54 minus 12. Okay, so it basically greater than 0. So it is positive, right? So f of x will obtain minima, right? Minima at x equals to 3. Then again, just put f double dash of 1. I will get 6 into 1 minus 12, that is basically minus 6. So less than 0. So f of x will obtain maxima at x equals to 1. Okay, so that's it. So option A is correct. Okay, we are getting maxima at x equals to 1 and minima at x equals to 3. Now if we want to find out the maximum and minimum value, just find out f of 3. So it will give me the minimum value of this f of x. And try to, if you want to find out maximum value, that is maximum value, just put f of 1, right? So you will get a maximum value. Okay, so this is how we find out maxima and minima. So this is question number 3. Again, same type of question. Function is given to us y. We need to find out maximum, minimum, or neither at x equals to 5, right? So same thing, just differentiate it. Dy by dx is basically a 2x plus derivative of 250 into derivative of 1 by x is basically minus 1 by x square, right? So 250 minus of x square, right? So that is basically 2x minus 250x square, right? So just equate it to 0 to find out the stationary point. So what I will get, dy by dx equals to 0. So basically 2x minus 250 x square equals to 0, right? So 2x equals to 250 x square. It is basically x cube equals to 125 and x equals to 5, right? So here we have x equals to 5 and the question is that the function y at x equals to 5 attains. So it means we need to differentiate this 2 times. So d2y dx square, or we can say f double dash of x equals to, just differentiate this again. So derivative of 2x will be 2 only, minus derivative of this 250x square. So 250 derivative of x square will be, that is x to the power minus 2 will be minus 2 into x to the power minus 2 minus 1, that is minus 3. So minus 2 to the power x to the power cube, right? So if I just simplify this, 2 minus 500, sorry, plus 500 x cube. So if I put the value of 5, anyway, the value of this particular f double dash of x is always greater than 0, right? If I put the value of 5, so if f double dash of x is greater than 0, it means f of x will attain, f of x will obtain minima, right? That is minimum value. So option B is correct. Okay. Now question number 4. Consider the function f of x where x is a real number. Then the function has only one minima, only two minima, three minima, or three maxima that we need to find out. Okay. So same step we have to follow. Okay. Same concept we have to apply in every question. So calculate f dash of x first. So it will be 2 into x square minus 4. Again, derivative of x square minus 4, it is basically a 2x, right? So just simplify it. 4x into x square minus 4 equals to 0. We have to equate f dash of x to 0, right? So if I just say that 4x equals to 0 or x square minus 4 equals to 0, that means x equals to 0 or x square equals to 4. That is basically x equals to plus minus 2. So here I have three stationary points. First one is x equals to 0, then 2, then minus 2. So here I have three stationary points. Now I need to find out the whether it will attain minima or maxima, right? So just differentiate this f dash of x one more time, right? So what I will get? So you can simplify this equation first. So f dash of x will be 4x cube minus 16x, right? Now differentiate one more time. F double dash of x will be 3 4s are 12x square minus 16. Now just try to put the stationary point in this f double dash of x. So f double dash of 0 will be 12 into 0 minus 16. So this minus 16. So negative less than 0. So it will obtain minima, sorry, maxima, right? It will obtain maxima at less than 0, right? What about f double dash of 2? So 12 into 2 square minus 16. So 4 into 2, that is 12, that is 48, right? So 2 square is 4 into 12, that is 48 minus 16, that is basically 32, greater than 0. So it will obtain minima. It will obtain minima at x equals to 2, right? What about f double dash of minus 2? Same thing, 12 minus of 12 into minus 2 square, that is basically minus 16. So same thing, 32 greater than 0, right? So same thing at x equals to minus 2. So how many times it is obtaining a minima or maxima, we need to find out that, right? So here you can see the function f of x will attain a maxima at x equals to 0, right? And it will attain the minima two times when x equals to 2 and when x equals to minus 2. So only two minima is the correct option, right? So option B is correct because this f of x will attain the two minima when x equals to 2 and when x equals to minus 2, right? So question number 5. The function f of x is given to us as its maxima at. So same thing, same process we have to apply. What is f dash of x? 6x square minus 6x, right? Minus 36. For finding out stationary point, just equate it to 0. That is f dash of x equals to 0. So 6x square minus 6x minus 36 equals to 0, right? So divide by 6. So x square minus x minus 6 will be equals to 0. That is basically x square minus 3x plus 2x minus 6 equals to 0, right? So x common, that is basically x minus 3 plus 2 common, x minus 3 equals to 0. So x minus 3 and x plus 2 equals to 0. It means x equals to 3 and minus 2 are my stationary point. Okay. Again, again, in order to find out maxima and minima, again differentiate this f dash of x. So f double dash of x will be 12x minus 6. So just try to put the stationary point. So f double dash of 3 will be 12 into 3, 36 minus 6 will be 30. So greater than 0. So it will attain the minima at x equals to 3. What about f double dash of minus 2? So 12 minus 2 minus 6. So we will get minus 8 minus 30, right? So it's basically negative, so it is less than 0. So we'll get maxima at x equals to minus 2. Okay, so we'll get maxima at x equals to minus 2 only. Option A is the correct one. Okay, simple question. So question number 7, right? The curve y equals to x to the power 4 is concave up for all values or concave down. So we need to find out, right? So how to find out this particular uh, so how to solve this particular question? By using maxima and minima concept, right? So if you know, the graph of x to the power 4 is like this. Okay, it is x, this is y, and it is like this. So it's even power of x, right? So it is like this. So from the graph we can directly tell it is concave up for all values of x, right? It will be minima here like this. Okay, but how to how to solve this type of question using minima and maximum, right? So we have y equals to x to the power 4. Just differentiate it. Dy by dx equals to 4x cube, right? But can I find out the stationary point for this particular dy by dx? So if I try to equate to 0, what I will get? 4x cube equals to 0. That is basically x equals to 0, right? Right. And again, if I just differentiate this particular expression, that is basically d2y by dx square. Here I will get 12x square, right? Now, if you observe, so this is 12x square. This is a double derivative of this particular y. So it will always be a positive. So this value will always be a 0 for irrespective value of x, because it is x square, right? So even if the value of x is negative, it will always be a positive because we are taking the square of it. So this particular function will always attain a minima. Okay, always obtain a minima, right? And here you can see this is the graph for it. If there is only one minima like this, okay, so here you can see, here we have minima. So when this particular graph is having only one minima, it means it is concave up, right, for all the values of x. So option A is correct. And suppose I have a graph like this. Okay, so this particular graph will always attain the maximum value at this particular point. Okay, this maxima. Okay, so please remember this into important point. So the answer of this particular question is option number A, concave up for all values of x. Okay. Okay, so this is question number 8, right? Now the maximum value attained by this particular function in the interval, closed interval 1 comma 2, right? So same concept we have to apply. Just differentiate f dash of x, but it will be difficult to differentiate this one due to multiplication. So first try to simplify it. So what I will get? X square minus x, right? X minus 2. So x cube minus 2x square minus x square plus 2x, that will be x cube minus 3x square plus 2x. So this will be my f of x after simplification. Now just take the derivative f dash of x. So 3x square minus 6x plus 2 will be my f dash of x. Now we need to find out the value of this particular equation, right? Root of this particular expression. Now we need to find out the value of the now we need to find out the root of this particular equation, right? So just equate it to 0, f dash of x equals to 0 to find out the stationary point, right? That is basically 3x square minus 6x plus 2 equals to 0. So do we have any two number integers such that if we just like 3 into 2 is 6. So can we get two numbers such that the product is equals to plus 6 and their addition will get equals to minus 6? Do we have such type of numbers? No, right? So what we can do, we have a generalized concept to find out the roots. That is basically x equals to minus b plus minus of b square minus 4ac divided by 2a, right? So this is the formula for calculating the root of a quadratic equation. Okay, so root of a quadratic equation. So equation is like this: ax square plus bx plus c equals to 0. So if you compare this equation with this equation, so what I will get? A equal to 3, b equals to minus 6, and c equals to 2. Just try to put the value. So what is the value of x? That is basically a root. So minus of minus 6 plus minus under root of b square, that is basically 6 square, minus, that is minus 6 squares, but 6 squares, okay, minus 4 into 3 into 2 divided by 2a. What is 2a? 2 into 2, 2a, sorry, 2 into 3. So that is basically a 6 plus minus of 36 minus 24 divided by 6, right? So it is basically a 6 plus minus root 12 divided by 6. I can write this equation root 12 as 4 into 3, that is 6 plus minus 4 into 3 divided by 6. So 4 is basically a 2 square, right? So I can write it as 6 plus minus 2 outside the square root, root 3 divided by 6, right? Now if I just divide by 6, so what I will get? 1 plus minus root 3 by 3, right? So this is the root of this particular equation. So my stationary points are x equals to 1 plus root 3 by 3 and 1 minus root 3 by 3, right? Now what is the value of this particular term and this particular term? Just you can just find it out, right? So it will be 1 plus root 3 by 3, right? Right, so the value of this particular thing will be 1.577 and the value of this particular expression will be 0.43, right? So these are my stationary point. But if you observe, this second point 0.43 does not lie in my interval, that is 1 and 2. It is less than 1, right? So it does not comes in, so it does not comes under my interval 1 comma 2. So we are not going to consider this particular stationary point. Only we have one stationary point here, that is 1.577, right? So while solving such type of question, please be careful that whether our stationary points are lying in the whether our stationary points are lying in this interval or not, okay? Because this point is not lying on this interval, so we are not going to consider this. So in this case, we have only one this particular point, that is 1.577. Now just try to put the value of 1.577 in the f of x. So what I will get? F of 1.577, right? So 1.5, just for example 58 into 1.58 minus 1 into 1.58 minus 2, right? So if I calculate, this is positive and this is negative, right? So if I calculate, the value of this particular expression will be minus 0.385. So you can use the calculator for doing this type of calculation, okay? So we have a calculator on the portal, so please try to use that calculator, because in the during exam time you have to do such calculation using that calculator only. So better to practice now only, right? So here we got minus 0.385, but in order to find out maximum or minimum value, we have we have to check with the intervals also, because these are the close interval, right? So what is f of 1 here? So f of 1 will be 1 into 1 minus 1, 1 minus 2, so 1 minus 1 is 0, so basically 0 only. What about f of 2? Same, 2 minus 2 will be 0, so 0. So which one is maximum? So maximum of f of 1 comma f of 2 comma this f of x0, it is critical point local maxima. So maximum of f of 1, f of 2 and f of 1.577 is 0, right? So our f of x will attain a maximum value only at the end point, that is 1 comma 2, and that value is 0, okay? So maximum value of this particular function is 0 only. So please remember this point, okay? Because for this stationary point it is coming negative, but 0 is greater than negative, right? So so the answer will be 0. Okay, so this is question number 9, right? Now if you observe, up till now we have discussed the function which is having only one variable, that is x. Now in this case we are having two variables, that is x and y, okay? This is the expression or equation in the form of x and y. So how to solve such type of question, how to find out maxima and minima, okay? So for maxima and minima for a functions of two variables, okay, so let z equals to f of x comma y be a function of two variables, right? So what is the working rule here? So first step is to find out the p, q, r, s and t. Now what is p, q, r, s and t? P is basically a differentiation of f with respect to s, that is df by dx. What is q? Q is basically differentiation of this particular function with respect to y, that is df by dy. Okay, so p and q is, p is basically a differentiation of this particular function with respect to x, and q is a differentiation of this particular function with respect to y. Okay, and what is r, s and t? So r is basically a double differentiation of this particular function d2f by dx square, that is basically my r, right? And what is t? T is basically a double differentiation with respect to y, this dy square. So it is basically, now what is s here? So s is basically a, first differentiate f with respect to x, again differentiate this particular thing with respect to y, so it is d2f by dy into dx. Okay, so this is basically a s. So please keep a note of this: what is p, what is q, what is r, what is t, and what is s. So first thing is to find out the p and q and equate it to 0 to find out the stationary point. What is p here? It is df by dx, right? So if I differentiate this expression with respect to x, treating y as a constant, okay, treat y as a constant. So what I will get? 3x square minus 6x, right? What about q? It is df by dy. What I will get with respect to y and treating x as a constant? So 8y only, right? If I equate it to 0, what I will get? So basically, 3x square equals to 6x. So x will get cancelled. X equals to 2, right? And here, if I equate it to 0, y equals to 0. So these are my stationary point, right? So these are my stationary point. My stationary point is 2 comma 0, right? Now my third step is find out the value of r, s and t. So what is the value of r? That is double differentiation of f with respect to x. So that is r is basically d2f by dx square. So what is the value of double differentiation of this? So it is 6x only, right? This 6x minus 6, right? What about t? T is basically d2y by d2f by dy square, right? Differentiation with respect to y of this particular expression, that is 8 only. And what about s? So first differentiate with respect to x, then differentiate the same term with respect to y. So here if I differentiate the same term with respect to y, because y is not present, so treating x as a constant, so I will get 0. So value of s is 0, value of t is 8, and value of r is 6x minus 6, right? Okay, now just put the value of x here in the in r. So what I will get 6 to 12, 12 minus 6, that is basically 6, t equals to 8 and s equals to 0, right? Now consider rt minus s square. What I will get? 6 into 8 minus 0 square, that is basically 6 is 48, which is greater than 0. If rt minus s square is greater than 0 and r is greater than 0, so in this case r is also greater than 0 and rt minus s square is also greater than 0. If both the things are greater than 0, then f of x comma y will has the minimum value at that stationary point, right? So option B is correct. So this particular function will attain a minimum value because this rt minus s square is greater than 0 and also r is greater than 0. Okay. So first you need to calculate p and q, equate it to 0, find out the stationary point. Then right now consider r, s and t, where r is d2f by dx square, t is d2f by dy square, and s is d2f by dy into dx, right? Dy by so, so s equals to d2f by dy dx, right? Now then just put the value of the stationary point in r, s and t and find out the value of rt minus s square. If it is greater than 0, then it will have the minima or maximum value based on the value of r, right? But if it is less than 0, it means it has no extrema value. It means it has no extremum value. It means there is no maxima and minima, and such points are called as saddle points. Okay. And if it is equals to 0, then the case is undecided. Please remember this point, right? So please go through this working rule. We have provided the notes in that I have included all those things. Okay. So correct option will be option number B. That is minimum at what stationary point x comma at what stationary point 2 comma 0. Okay. 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 So this is question number 10, right? A political party orders an arch for an entrance to the ground, okay, in which the annual convention is being held, okay. The profile of the arch follows this particular expression, that is Okay, so it is 2x square, right? So it is y equals to 2x minus 0.1 x square, where y is the height of the arch in meters. The maximum possible height of the arch is, so maximum possible height. What is height here? Y, right? So we need to find out the maximum value of y only here. That's it. Simple question. So how to do that? Same thing. Differentiate y. Okay, that is basically dy by dx. What I will get? 2 minus 0.2x. Just equate it to 0 to find out stationary point. Equate it to 0. What I will get? 2 equals to 0.2x. So x equals to what? 2 divided by 0.2. It is basically a 10, right? X equals to 10. So at x, right? So x equals to 10 is my stationary point. Now again differentiate it. Again differentiate y with respect to x. So d2y by dx square. So in this what I will get? Minus 0.2. So anyway, irrespective value of y, this is less than 0. So I will get maxima value, right? I will get maxima value, right? I will get maxima at x equals to 10. So just put value of x 10. So what I will get? Y equals to 2 into 10 minus 0.1 10 square. So 20 minus 100 into a 0.1, it is basically 10. So answer is 10. So the maximum possible height of an arch is 10. Okay. So simple concept. So that's it from this particular lecture. So only few points are there. First thing is that f of x. So we have discussed all the steps. You have to follow that only. Second is f of x comma y using two variables. So please remember these rules because they can ask such type of questions. Okay. So that's it from this particular tutorial. Thank you.